Hello everyone. Let me begin with the question. Have you ever wondered how autonomous cars manage to see their surroundings and make decisions in real time? That's the magic of sensor fusion, a topic that's shaping the future of technology. I am Shivakumar Hridaykumar Patel. My student ID is 175539212. I'm going to talk about the sensor fusion methods. I'll take you on a journey through the fascinating world of sensor fusion methods. Let's dive right into it. So, to set the stage, let's define what sensor fusion is. What do you mean by sensor fusion? Es- Essentially, sensor fusion combines data from multiple sensors to improve accuracy and readability, far beyond what a single sensor can achieve. Imagine a smartwatch monitoring your health. It does not rely on just your heart rate, but also track oxygen level, motions, and temperature of your body. That's sensor fusion in action. It's a game changer in fields like robotics, autonomous vehicles, and IoT applications. So, throughout this presentation, I will be showing you why it's so critical and how it works. So, let's talk about the why. Why we need sensor fusion. Let's take an example of autonomous vehicles. A camera alone may fail to detect an obstacle in poor lighting conditions, but by integrating data from LiDAR or radar, the vehicle can make safer and more reliable decisions. Sensor fusion does not just add layers of accuracy, it also brings redundancy, which is vital for safety critical systems. Think of it as creating a safety net where each sensor supports the others. Let me give you one question. Can you think of other areas where combining data from different sensors might be crucial? Just feel free to share your thoughts. Now let's break down how sensor fusion works. The process has three main steps. First, data collection, gathering raw data from various sensors. Second is alignment, in which synchronizing and aligning the data in terms of space and time. And lastly, processing, using algorithms to fuse the data and extract meaningful insights. For example, in a self-driving car, GPS provides location, cameras identify lanes, and radar detects nearby vehicle. The fusion system integrates this data to create a cohesive understanding of the environment. So here's where it gets technical. But don't worry, I'll keep it simple. We use various algorithms for sensor fusion depending on the application. First, Kalman filter, which is which is perfect for predictable patterns or the system which have a predictable patterns like navigation. Second is particle filter. This one shines in dynamic environments like tracking down the robot's location and everything. Third is a complementary filter, which is a lightweight option for balancing short and long-term data, mostly used in drones and AI methods. These use deep learning to adapt and handle complex and noisy data. Let's make it tangible with some examples. First of all, autonomous vehicles is the biggest example of application of sensor fusions. Uh, Autonomous vehicles have a combination of lidars, cameras, and GPS to navigate safely. Secondly, robotics has a main use of sensor fusion. They use SLAM, which is simultaneous localization and mapping, to map environments around them. Third, uh, in healthcare, they are used in wearable devices for health monitoring, like heart rates and movement. And last but not the least one, in IoT sectors, smart home integrated sensors data to optimize energy and security. Now, let's talk about challenges in sensor fusion. Of course, no technology is without its challenges. For sensor fusion, let's include first of all, calibration issues are coming up. So, aligning sensors accurately is very tricky. Second, processing delays. In real time, fusion can be complicated and uh, not be on time. Third, which is noisy data. Sensors often produce conflicting or incomplete data. Overcoming these challenges is key to unlocking the full potential of sensor fusion. Let's talk about real world examples. Autonomous vehicles are the flagship applications of sensor fusions. They integrate LiDAR for 3D mapping, cameras for object recognition, and radar for distance measurement. These sensors work together to ensure safe and accurate navigation, even in complex environments too. So, for example, during testing, Tesla's systems often rely on fusion to predict potential hazards well before they were visible to the driver. Now, let's think about the future. The sensor fusion will also be very important in future and very useful. First, in AI-driven fusions, like machine learning will make fusion system more adaptive. Edge computing, like local data processing, will be faster and decisions will be taken precisely. For drones and IoT, in quantum sensors, these will dramatically improve precision. And in multimodal fusion, combining more diverse sensor types for richer insights. The future of sensor fusion isn't just about better technology, it's about transforming how we interact with the world around us. So, before we wrap up, I have to acknowledge the incredible work that informed my presentation. I have used some book references as well as Wikipedia references, which are described over here. The best book for the sensor fusion is An Introduction to a Kalman Filter, which I have read, which is written by Bishop and Welch G. And the second one is Probabilistic Robotics, which is written by Thoran. So please try to use those books if you want to gain knowledge about sensor fusions. And thank you so much for your kind attention. And thank you so much for my presentation too.